Okay, so we're going to get into the trig section in the course now. One of the things before we get into that trig is to actually look at a review of grade 10. This is RF1, it's actually G3, so we'll change that here. So this is the curriculum outcome we're up to now. It is G3 in the course, and it'll be labeled like that within the iTunes University. So that's our curriculum outcome. We're going to be looking at the cosine law and the sine law. And part of that is to know what we're talking about when we say sine, cos, or tan, opposite, adjacent, hypotenuse, all of that terminology which you got in grade 10. So we're going to go back over that, how to label triangles. All of that's assumed, but I'd like to get a good review of that before you start into actually using the sine law and the cosine law. So here's the first part of our trig review. Right, we've got a right angle triangle. So there's our square in the corner indicating it's a right angle triangle. The side across from the right angle is always the hypotenuse. Then in order to label the opposite and the adjacent, you need to have a reference angle. Right? So which angle am I speaking about? Well, in this case, it's this angle right here. And I like to think about the actual terminology to help me out in remembering which side is the opposite and which one is the adjacent. Right? So opposite, I said on the opposite side of the room would be across the room. So the opposite side is the side that is across from your angle. So there's your opposite. Adjacent means next to. So the side that's next to your angle is the adjacent. And then that gives us the terminology we need, or the size that we need in order to be able to define what the sine of an angle is. It's the opposite length of the hypotenuse length in a triangle. The cosine of a reference angle is the adjacent length divided by the hypotenuse length. Right? And the tan of an angle, the reference angle, is the opposite of the adjacent. Now, those are your basic definitions that we learned last year. Another thing is actually labeling a triangle and using your labels to define things about the triangle. So what I've got here is just some really short terminology to draw a triangle. And this particular one that I have here isn't a right angle triangle. But that doesn't really matter when it comes to labeling angles and side lengths. So let's draw any old triangle here. It doesn't matter what it looks like. You can draw any old one like this, and you label it. Your vertices get capital letters like this. Then the side lengths get small letters. Side length A is the side that's across from or opposite from A. So this would be side length A. If it's talking about side B, and across from the angle B is side B. And across from angle C is side C. Notice the side lengths get small case letters, the angles get uppercase letters. So with our triangle just generally made, and when we're doing these questions, it gives you just information like this. You don't need a masterpiece, it doesn't need to be perfectly accurate. You just need something like this already labeled, and then you can fill in your information. So my thing here says the measure of angle A is 45 degrees. So I can write in 45 degrees in that angle. The measure of angle B is 64 degrees. So right here is 64 degrees. And then it says side A, so just little a, is 15 centimeters. So this is my side A. So it's 15 centimeters. I really should have been doing these in red. It helps to visualize what's going on. So that's how you actually use some shorthand and label triangles. Again, angles get capital letters, side lengths get these smaller case letters. All right, more review. So let's take this triangle, we'll put a couple of measurements on it. Let's go with the 3, 4, 5 triangle like this. And let's say that I wanted to do the sine of theta. So in order to do the sine of theta, I need to label my triangle. So you notice I've already got this label. Here's my theta, so this is my opposite side, this is my adjacent, this is my hypotenuse. So then the sine, go back to our previous notes, is opposite over hypotenuse. So it's going to be my opposite length of 4 over my hypotenuse length of 5. Now let's go to a bigger triangle over here. Again, same type of triangle, but let's put some bigger measurements on here. Let's this time say we're going to do 30, 40, and 50. And this time let's do the cosine of theta. So for this one, cosine is adjacent over hypotenuse. So for this one, it would be 30 over 50. Now, technically that is correct, but you wouldn't find that answer in the back of the textbook. The reason is that fraction can be reduced, and you should reduce any fractions if you can. So the top and the bottom are both divisible by 10, so that leaves you with the cosine ratio of 3 over 5. All right, so next one. Now let's say I've got this triangle. I want to find the actual angle theta. So how do we do that? First, we're actually going to take the information we're given and figure out what the ratio for this triangle is for sine. So sine is opposite over hypotenuse. So in our case, the opposite length is 5. My hypotenuse length is 12. Now, that's my ratio of opposite to hypotenuse. That isn't what my angle is. Now, fortunately, we have calculators that know the ratio for any angle. So if you give the ratio, it can tell you the angle that would create that ratio. So let's go into our virtual TI here. And to get what the angle is, you're going to do what's called the inverse sine. So in these calculators, it's above the actual sine. So you go second inverse sine. So what I'm asking the calculator when I say inverse sine, I'm saying what angle creates a ratio of 5 over 12. So you put in, you tell the calculator, well, my ratio is 5 divided by 12. Those are brackets here. And hit enter. Okay, so 24.6. So we'll round that to 25 degrees. Okay, so the answer here then is 25 degrees. Okay. So let's go down. Try another one. So this one, notice there's nothing given. They just give you a triangle, some information, they've got a couple of sides, and they tell you the reference angle. And they say, all right, you've got to find what that angle is. Okay. So it's always good to label if you can, so it's not already labeled. So we'll do A, B, and C like this. So and then A is across from here. This is C, and this is B. And then we can start to label opposites, adjacents, hypotenuse. Since this is my 90-degree angle, then this has to be the hypotenuse. Right? And then since theta opposite is across from, so this is my opposite side. And this would be my adjacent side. And I look at what I have. What information do I have? Well, I don't have the hypotenuse, but I have the opposite and the adjacent. So you go back to your definitions here. You say, which one of my ratios, sine, cos, or tan, has opposite and adjacent? Well, only tan does. Okay, so we go back here, and you say, well, if I do the tan of my reference, I'll have both pieces of information. I know that the tan of my theta is opposite over adjacent, or 7 over 9. So then, once again, you can go back to your calculator and tell it, I want to know what angle gives me a tan ratio of 7 over 9. So you do the inverse tan. And then you tell the calculator, my ratio is 7 divided by 9. I'm saying what angle creates that ratio? The calculator tells you 30 degrees. Okay, so there's finding a missing angle. Now, let's do a missing side. So let's put a reference angle down here. Obviously this is my 90. And let's put a, let's call it a 7 here and maybe a 15 up here. And I want to know, oh sorry. Say that I want this side length. I want to know what is the length of the side, right? And you would have been given that theta is, let's say, 35 degrees, something to that effect. Okay? And again, I look at my information, what have I been given, and then I'll label my triangle. There's my reference angle. Obviously, this is your hypotenuse. This is your opposite side for my reference. This is my adjacent side for my reference. So the side I'm interested in is the adjacent side, and the side that I actually have some information for is the hypotenuse. Okay. So since I have the adjacent and the hypotenuse that are involved in this, that's cosine. So I know that the cosine of my angle, which is 35 degrees, is equal to x divided by 15, my adjacent divided by my hypotenuse. So you might be saying, well, how is that going to help me right there? You know, I've got this cosine of 35 degrees and 15. I can't solve for x yet. Well, your calculator also knows what the ratio for any angle is. So if I know my angle, then my cosine, my calculator can tell me what the ratio is. So if I put in cos of 35, it's going to, my calculator tell me what the ratio is. Okay. Now you might be saying, well, that's not a ratio, that's just a number. And it's a decimal number. Well, it is a ratio in a sense. It's just a ratio with 1. Your calculator always reports the ratio as a decimal to 1 or some number, and 1 as being the number that it's in ratio with. Right? So this is my ratio. So now I can fill in here 0.819 is equal to x divided by 15. So now I can actually solve for x. My x is right now is divided by 15. I need it all by itself, so the opposite operation would be to multiply by 15 on both sides. That'll get rid of it on that side. Nice thing about these calculators, instead of retyping that and multiplying it by 15, I can just go times, and it takes that answer, and multiply it by 15, enter, and I get 12.3. Okay, so x is equal to 12.3. As an aside, for those of you that are in science, I kept one too many significant digits here. This measurement only had 2 sig figs. This one had as many as the calculator would give me. I only wrote down 3, but technically if we were in science and doing some type of actual measurements, we could only report 12, we would round 12, just as an aside. But I'm not going to be that picky when it comes to the course. If you give me 1 or 2 decimal places when the sig figs told you shouldn't give any, I'm not going to be really picky with that. Yep, that's it. So there's your review. And there's a review sheet that goes with this. I think this is it right here. Okay, so it's giving you a few questions. It starts out with a really simple, what's the ratio? So there's the angle x. What's the sine of angle x? Right, well, opposite over hypotenuse would tell you 40 over 41. Okay, I also gave you, with the review, the answers to make sure you're getting it correct. So if you're not getting the answers, then you need to raise your hand and ask me why am I not getting the answers. Okay? And when we finish this, and you've got the review down pat, then you can move into the assignments that go with this section.